Hello everyone, welcome back to the 5 Minute Tech channel. Today we will be talking about C# design pattern, and this is the first part of the series in which we will be starting with the creational pattern, which is the factory method pattern. So let's get started. So before we get started, let's talk about the design pattern as a whole. Design pattern in our object oriented world are the reusable solution to common software design problems which we face every day, and that repeatedly occurs in our real world application development. It is more or less a template or description on how to solve these problems that can be, and those solutions can be used in many different situations. So first of the design, one of the first design pattern is the creational pattern. Now this creational pattern is one which deals with the object creation, abstract the object instantiation process, and helps us with making our system independent on how its objects are created, composed or represented. Now these creational patterns are factory, abstract, factory, builder, prototype and singleton. I have marked the important ones in green and we'll be talking about them in detail, whereas we will be covering all these design patterns as well. The second one is the structural pattern. This structural pattern deals with the ways to define relationship between classes and the objects, and they are concerned with how classes and objects are composed to form large structures, and those are adapter, bridge, decorator, composite, facade, proxy and flyweight. And the third one is the behavioral pattern. These patterns deal with the way to communicate between classes or objects. It characterizes the complex control flows that is difficult to follow at runtime, and it lets us concentrate on the way the objects are interconnected. Then there are some add-ons like repository pattern and dependency injection pattern. These patterns are kind of implemented along with the other patterns. So in this session we will be talking about the factory method pattern, which is a creational pattern. So let's get started. Factory method pattern, what is the intent of it? The intent of factory method pattern is to define an interface for creating an object, but to let subclasses decide which class to instantiate, and the factory method lets a class defer instantiation to a subclass or subclasses. Now factory method pattern, this is the basic UML diagram and its implementation. This is a basic flow how it happens. We have a product now that has a concrete product. We have a creator which has a concrete creator. Now the creator can have factory method and operation, whereas a concrete creator will have factory method. So I'll talk in detail about this with a practical example in the coming. Now let's dig deeper into it with a practical example. So most of us are aware of the payment method, wherein we kind of enter a card or maybe a UPI detail or use net banking and all. So in this example I'll be talking about two payment methods. One is the card and the UPI. So consider there is a payment service you have written which takes value of amount which has to be deducted. For example, here it is 15,000 rupees, and that can be done through a card payment service or a UPI payment service, and that internally will have its card payment factory and UPI payment factory, which in turn will have the payment service. Now if you see the flow, this is the same as you saw in the previous diagram. There was a product, there is a concrete product A, concrete product B, concrete creator A, concrete creator B, and the creator. The creator maps to payment service, whereas concrete creator A and B maps to the type of factories we have: card payment factory, UPI payment factory. Concrete product A and product B are the types of payment. For example, this is the card payment or the UPI payment, and our product is the payment. So this is how it works, and product basically defines the interface of the object that the factory method creates. Concrete product implements product interface. The concrete creator implements the creator and overrides the factory method to return an instance of the concrete product, and the creator declares the factory method which must return a product. So this is how the payment service is an example of the of how factory method can be implemented. We will be talking about this in a complete demo. So let's start with the demo, and in this I will be creating a project from the start, and we will create a full structure of the factory method pattern. So here I have a basic ASP.NET web application wherein you see the basic code is there. I will just remove this basic code now. So let me delete this basic implementation of weather forecaster. I'll go ahead and add a service, that is a class. I'll name it as a payment service. Now in this payment service, I will first of all mark this as an abstract class. And then I will add our charges. Now I will just keep get because I am going to get the values from this service. Now I will create payments. There are two types of payments, one card and UPI. I'll create a card payment service. Now this will inherit from payment service. I will provide an input parameter which is the card number, and I will create a constructor, and this constructor will take this card number, which is a string property, and then I will override charges, and it will be let's say it will return 200. Let me annotate it like this, little easier to read. And then I will be creating a UPI payment service. So public class UPI payment service. This will also inherit from the payment service, and this will also have the provider. So here I will be taking a provider, private read only string of UPI provider. On that basis we'll have different charges. And then again I will create a constructor, and this will take the UPI provider and map this to UPI provider, and then I will do the same override. This time I will be doing little more logic, because on the basis of the UPI provider I will have different logic going on. So let me just keep this one, and do this. I will write a switch here, and this will be the UPI provider, and then I will write the case, which is consider it is Google Pay. The value which will be returned is 200, and if it is phone pay, I'll be returning maybe a little less, like 199, and then the default will again be 200. So what we have done till now is we have written a UPI payment service, a card payment service, and the basic payment, a base class which is the payment service. Now let's get into the factory method pattern. In this we will be doing is we will be creating specific methods, classes. So the first thing which we will be creating is a payment factory, abstract class payment factory, and this payment factory will have abstract public abstract payment service, abstract payment service, abstract payment service, and I'll just call it create payment service. So that's the payment factory. The next part is creating a card payment factory and the UPI payment factory. So we'll get started with that. Public class card payment factory. This will inherit from payment factory, and this will have this constructor, and before that we will have the same property, that is private read only card string card number. It will take the card number, string card number, and then we will have we will implement this override, and we will return new card payment service with the card number. So this is the card payment factory, and this was the payment factory. Now we will write similarly for our UPI payment factory. So I'll just copy paste this one, and let's do this quickly. UPI payment factory, UPI payment service. This will not card number, this is the UPI provider. I'll just correct this one so that they are not the same, and this is about it. So we have the same pattern which we just saw: a payment service, a card payment service, a UPI payment service, payment factory, card payment factory, and UPI payment factory. Now the whole structure I'll just explain once again. So what we did was to create a payment service which has what the charges are. The card payment service implements the payment service and overrides and provides the value of that particular, how much charges will be there. UPI payment service inherits payment service and returns the amount which is there. Similarly, we created something called as payment factory. Now payment factory has the payment service. Payment service is something which we had here, and what it does, it creates the payment service, and that payment factory is inherited by the card payment factory, and the card payment factory returns the create payment service as the card payment service. with the card number. And similarly, UPI payment factory inherits the payment factory and returns your UPI payment service with the UPI for the UPI provider. Now we'll go ahead and bootstrap it with the API. So here we'll rename this as a payment controller. And we will remove all these things which we don't need. We remove this. We do not need this. We do not need this. We need is a get payment. Get payment amount. And this is something which we don't need. It will be a int get payment amount. And then here there will be I will do two parameters. Both of them will be optional. One is card number and the second one will be UPI provider. UPI provider. And I'll remove all this. And here is basic part which will happen now is I'll be calling the payment factory and I'll be calling the services. So let's get to code that. Now where payment factory is equal to new of payment factory. Here I will be having a collection, a single collection. And I will do is new. I will do first of all let me try UPI payment factory and I will pass in the UPI provider. Now I want to do it on a conditional basis, so what I will do is I will do string dot is null. This is just a simple implementation to just showcase how it will, the way you can use it. So I'm just doing this way on conditional basis. I am doing the payment factory creation, and then I will do is new card payment factory and I'm passing the card number. And then I will return payment factory, and since I have a single item in the collection I can do create payment service and I'll return the charges. So as you see here, I'm passing two parameters based on conditional operator. I'm either creating a UPI payment factory or the card payment factory, and using that instance I'm creating a payment service. And through that payment factory, which is either UPI payment factory or the card payment factory, it will give me the charges. So now let's get to run this. So now my Swagger has loaded and I will go ahead and call it out. So first of all I'll go ahead and do phone pay. Remember I had given it 199. So let me try running this and let's see. So I'm getting 199 as a response. Let me do GPay, and when I execute this I will get 200. Now I'll remove this and I will enter some random card number, and when I execute it I will get 200. So this is how the factory method pattern is implemented. So that was a short demo of the factory method pattern. Now let's get into when to use the factory method pattern. The subclasses figure out what object should be created. So when you have a scenario where the subclasses need to figure out what object they need to create, parent class allow later instantiation to subclasses, meaning the creation of an object is done when it is required, as you saw in the payment services. The process of object creation is required to centralize within the application, and the class, which is the creator, will not know what class it will be required to create. So this is just some scenarios for which you would be creating a factory method pattern or using the factory method pattern. Pros and cons of factory method pattern. Factory method pattern eliminates the need to bind application specific classes to your code. As you saw, I was just calling a payment service and I don't care about what happened inside the UPI payment service or a card payment service. New type of product can be added without breaking client code, that is the open close principle. And then creating products is moved to one specific place in your code, which was our payment service, and that is the single responsibility principle. The cons is the client might need to create a subclass of the creator class just to create a particular concrete product object. So we have to create those classes. As you saw, there were 4 or 5 classes which we create, and if you need some more implementation, you will have to create more classes around it. But it does create an isolation of responsibilities. Moving on, what are the related patterns to the factory method pattern, which we'll be covering in the future sessions, is abstract factory method pattern, often implemented with factory methods. Prototype pattern, no subclassing is needed, not based on inheritance. Prototype is not based on inheritance, but an initialize action on product is often required. And the template method pattern, where factory methods are often called within the template methods data to us. So that was all about factory method pattern. Hope you like this session. If you like this session, do like the video and subscribe to the channel if you haven't yet.